Live from New York, it's Ask an Engineer.
Hey everybody, and welcome to Ask an Engineer. It's me, Ladyada the engineer. With me, Mr. Ladyada, camera control and behind the scenes. We're here. We're on Discord. We're broadcasting live from downtown Manhattan. It's just me and Mr. Ladyada, and Baby Ada is resting peacefully. But we got an exciting show for tonight. Lots of electronics, new products. It's not out yet, and more. Kick it, Mr. Ladyada. What's on tonight's show?
On tonight's show, the code is ClearKnob.
Ooh.
10% off in the Adafruit store all the way up to 11:59 p.m. That includes free stuff, so we'll talk about the free stuff in just a second. Adafruit Live just got finished up with show and tell. There was some awesome, amazing show and tell, folks. Thank you for coming by. We'll talk about a couple of the projects, but make sure you watch it across all the different places where we post our vids, which is pretty much everywhere. Talk about Desk of Ladyada, including what we did for Great Search, JP's product pick of the week, some New York City factory footage. We got a twofer, which is 3D printing and Adafruit I/O this week. We're going to do Ion MPI. We got some really cool top secret. We're going to do some new products. We're going to answer your questions. We do that on Discord, adafruit.it/discord or discord.gg/adafruit. We have our video going out on every place you can possibly stream. So we do all the questions on Discord. Hang out over there. It's easier to ask and get answers there throughout the show and especially at the end. All that and more on, you guessed it, Ask an Engineer. Okay, so first up, let's do a little bit of code stuff, housekeeping, and then we'll jump right in. So we got freebies.
Beep beep. Free me mobile.
Yeah. So what do they get besides when using the code? What do you get when you start out?
When you use the code, you get 10% off, but when you order $99 or more, you get a free half-size Permaproto breadboard. We'll go get back to those free nudes later, but we're waiting for some shipments to come in. At $149 or more, you get a free RP2040 dev board. This is the KB2040 with an RP2040 chip, STEMMA QT, buttons, 8 megabytes of flash, USB-C, castellated pads, and it's Pro Micro Pinout compatible. So it's a great board for all sorts of electronics projects. Free UPS ground shipping with orders over $199 and $299 or more, you get a free Microbit V2. It's a great microcontroller board that can run MicroPython or Arduino or CircuitPython, LEDs, sensors, buzzers, buttons, and more.
Okay, a little bit of a reminder for the folks who are seeing us on our show and also on our website. You can see this here. Starting March of this year, we're raising our purchase order minimum from $50 to $100 and removing the PO processing fee.
Yeah.
We used to have to charge a fee because it took us time to do these POs. And then we noticed no one else is really doing purchase orders under $50. So we said, well, we'll remove the PO fee, but the purchase orders need to be over 100. So this is for schools, for educators, and for other folks. But I told the team I would help get the word out because that saves everybody time and a little bit of money. Next up, I just have like one. I'm not going to do news really in the same way tonight because we have a lot of stuff to get through. But I've been waiting to use the salute emoji for a really long time because it's really funny to me. I don't know. Whatever. And so I want everyone to pour one out for the balloons that got shot down, the most recent ones. So it had Adafruit stuff in it, we think.
It looks like they used our SI something, the triple output RF.
Yeah, these are
emitter.
Basically science projects and things that are perfectly fine to do.
And legal.
And everyone got a little nutty about this stuff. Not aliens, not World War III. You could put a balloon up in the sky and it does all sorts of neat stuff. And you could look at the blog posts that we have about this. But a couple of our boards got shot down, it seems. So you did your service.
Godspeed.
I just think that emoji is really.
It is a really fun. Well, I think because it's not smiling, it's like serious.
Also, like I just imagined in my brain like sinking or something like burr 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 burr. I don't know.
Just like this little.
I don't know.
Little Adafruit board is kind of like floating into the waves.
Yeah, just sometimes there's certain things I'm just like there's a.
Yes, a lot of people use our Ultimate GPS modules because they're known to be good above I think 40,000 feet, and our RF emitters are very popular as well.
Yeah.
Yeah, anyways.
I'm glad we didn't get blamed for all of this. A couple of years ago, there was a Russian commercial airline flight, and it crashed. And it was not terrorism or anything. It was just a mechanical error. And they said, oh, there was a barometric pressure sensor issue. And so CNN Googled for barometric pressure sensor, and instead of looking at ones for airplanes or whatever, they just found our photo. So there's this like Adafruit
I
board,
was gonna say,
Adafruit logo, Adafruit board, and the black
it's like
background.
BME 280.
And then like a couple journalists are like, Adafruit's board in this Russian plane. It's like, no, it's not. And I had to email. I'm just like, can you please not say that? And can you update your post, or can you not like say it was an Adafruit board? It wasn't. And anyway, so I'm glad we didn't get blamed for these balloons. But our stuff was probably in days where the Russian thing, no. Okie dokie. All right, we just did a bunch of live shows. Thank you, JP, for hosting. It's hard to pick favorite. I'm not supposed to pick favorites, but
But
I'm just gonna talk about a couple tonight that I.
there were some cool ones.
Yeah, well, check out Anne's project that we just published. It's a really neat retro floppy project where you have a screen on it, and for the youngins, that save icon used to do something. And it was a floppy, so it's just a neat retro project from Circuit Python. And then Guy at the end had a really neat project, and I thought the comments were kind of funny that they were saying about it. So it's a face detecting device. This is Pete Warren's company, where this is a non-connected face recognition, and it sees your face on a little clock, and then it displays the wrong time. And the guy said, yeah, like on Twitter, I'm an evil person. Because it's funny, you do fun, whimsical projects and pranks and stuff like that. And there's like people that are just like miserable and angry, and they'll try to make you not want to do your project. So the guy said, oh, I changed it so it's 11:11 and it's whimsical, and you get extra wishes. But I thought this was a really neat project. It just shows how easy it is to glue these things together with maybe the minimal amount of code that looks at a face, recognizes the face, makes an action, changes the time, keeps real time, but then it can change, and then changes back, and it can do other things like store a small amount of face. I think like 8 or so, but it's non-connected, so you don't have to worry about your face data getting uploaded to the clouds. So I thought that was neat. So check that out. And it's CircuitPython, and there was example code, but now there's a library. So good work. And then also, Todd Bot is just on a roll. Made this beautiful synth and like this amazing music stuff. Good work, Todd. I mean, it was delightful. We were watching. If we're not hosting this show and tell, you're probably wondering what we're doing. We're watching it. On Sundays, we do Desk of Ladyada, and we do this in 2 parts. First part, you were showing the latest and greatest. What were you doing on Sunday as of this week?
Okay. Well, first off, I was showing the ESP30, sorry, the RP2040 tester brains board that I showed off a couple of times ago and we use now, because originally we are using TNC36 based boards that can get TNC36s, and so I use this opportunity to be like, okay, let's redesign these boards to use the RP2040 Pico, which I have tons of. And also really, it's a good board, and it has BitBang USB host now. So one of the things that we did already was we implemented RP2040 programming for RP2040. So it programs itself over USB, which is perfect because we have so many RP2040 boards. And now the next board that we are targeting is the ESP32 series, because traditionally I use a Raspberry Pi to program these, which is totally great and fun and works well, but I really like solid state programming as much as possible, like no SD cards, no Linux operating system, like no operating system is best. So we have those files for the tester brains are up on GitHub. You can download the boards and fabricate them yourself. They're completely unsupported. And then in the Adafruit test bed Arduino library, you can see all of our example code for programming boards from an RP2040 standalone, what we use for our testers.
And I might tell you something. So one of the things, just kind of working with Ladyada over the last decade plus, the engineering of the product for her isn't where I think the challenge really comes from. It's designing it for manufacturing and testing, because you crank through designs, but then it's like, how do you actually do a full like test?
Yield and test is actually, it's a second half, right? So this is the hidden half, because it's one thing to make something, but it's another thing to be able to make it quickly, efficiently, and perfectly. I'm on every customer support return.
And no one talks about this. No one
every failure
shares this.
I'm informed, so it's like it's in my best interest. Like every board that goes out is tested. Once in a while there's mistakes that occur, but like there's 100% test coverage, assuming people follow the instructions. But it has to be fast. Like if it takes minutes, and every few seconds counts. So like I was talking, this is not public, but behind the scenes talking to Tack, who's been writing this ESP32 programming code, and we're going back and forth every night. And we're like, okay, well, how can we shave 2 seconds off? It's like, okay, instead of programming it 921 kilobaud, how about we upload 2 megabits? Okay, that sped it up. Okay, let's do the stub loader because that allows you to send bigger packets of data. Okay, that sped it up. Okay, now there's a compressed file upload capability. So let's gzip the file. Okay, that sped it up. And like, how do we get as close as possible to, the optimal, as for example, you want to verify that the file was read instead of reading it back. You do an MD5 sum over the flash memory and you compare that. So it's like you don't have to read the file. You just compare. The MD5 sum is calculated much faster. So all these little things like add up because when you're making 1,000 boards a day, you multiply that by a minute each, you can see how
So check it
really
out.
adds
Like
up.
and we also looked around. Like no one else was sharing this. No one else was doing this, and we know because we get emails from people who run businesses. They're like, "Thank you so much. Like, I just took off 20 hours of our testing, or I took 40 hours difference between how I was doing it before and how I'm doing it now."
Yeah, so especially for folks doing ESP32, RP2040, we already have. It's very fast over the USB host. It works wonderfully. And then ESP32, we just did stubbed gzipped file upload from internal flash memory, so not the micro SD card, and that's because it's even faster when you don't have to do the micro SD card rewriting. So it's just 1 second, 2 second here, there, and we got it down, I think, to 10 seconds to write a 1 megabyte file to the ESP32, which is basically as fast as ESP tool does it.
I don't know if it was a rumor or whatever. It was like Steve Jobs is telling Steve Wozniak, like, make the boot up even faster because you're saving lives if you can get like 10 seconds, if you can boot up
Yeah.
10 seconds more. I don't know if that's,
Dude, fast boot is nice though.
I don't even know if it's a real story, but I like it.
Yeah.
So it's like, you can, sometimes there's a lot of fables, but there's lessons to be learned. But it's interesting. It's like, if you can save a few seconds off a boot up, that's actually human life. So when you think about
Yep. And then when we test again, if we're testing 1,000 boards a day, you multiply it out, it adds up real fast. So I like to get test for microcontroller boards. If I can test under 10 seconds,
that's good.
that's the way to go.
Right. Then we do the desk of Ladyada, where you also do the great search. We do the great search on desk of Ladyada. Yeah. But I said in reverse. So what did you help folks find on digikey.com this weekend?
Okay, so this week doing a board update. So I'm ordering the MacroPad PCBs, and one of the components, the PAM 8301, is not recommended for new designs, which historically would mean that I have a couple years before I need to swap it out. But with chip shortage, post chip shortage, I've noticed that NRND ends a lot faster, sometimes unexpectedly so. And so I'm always I'm much faster now to replace parts. So
what does that stand for the folks who aren't biz?
not recommend. NRND stands for not recommended for new designs.
Yeah.
So it basically means they're still selling it, but it's lifetime limited. They reserve the right to discontinue.
Here you go. Don't put in a new design because we're not going to help you.
Yeah. It's like buying the milk and it expires like tomorrow. Like in theory, if you drink it tonight, you're good, but still, not recommended
for new dairy.
For new dairy. So found a couple options, including, the PAM 8302, I think, and 8304, but also an NAU part as well. So a couple different options.
Okay. We're going to do some back-to-back. So JP's product pick of the week, that's when we broadcast live from the product page and give you a discount. And then I'm going to do a quick 1-minute video with JP's cat piano that I wanted to get out that he shows on JP's workshop because it's a really cute video. So here we go.
It is the ESP32S2 reverse TFT Feather. This is the 240 megahertz Tensilica processor on here. We've got 4 megs of flash, we got 2 megs of PS RAM. This can do Wi-Fi, no Bluetooth, but this can do Wi-Fi, 2.4 gigahertz Wi-Fi. It has the native USB, it has a USB-C on it, which I love. One of the nicest features of it is this panel mount option that you've got. And you can see there's the 4 little mounting holes. So I've mounted it into a little case that I made. I cut this out of acrylic on a laser cutter. And it gives me a kind of a neat little way to very quickly add an ESP32S2 Feather to a Eurorack project and mount it all in one. Here you can see it's just sort of a temporary solution here, and the jacks aren't connected up to anything. This is just sort of a proof of concept. It is the ESP32S2 reverse TFT Feather.
And don't forget, we have Deep Dive with Tim every single Friday at 2 p.m. Pacific, 5 p.m. Eastern. You can learn about how to make a lot of this stuff and all the innards of CircuitPython and more. Speaking of, it's Python on Hardware Time. We have a gigantic newsletter. There's a lot of things in it. I'll mention two things, and then we're going to talk about the thing that people are going to have questions about later. So I may as well just use that for this segment. So CircuitPython 802 is released. Bug fixes and more updates when we do a 8.0 release or any major release, then we immediately start to have some other releases afterwards. And then you can check out.
Great. I actually love that we do quick. Right after a big release, we do a lot of little mini releases.
Yeah.
Because it means that people are using it and they're getting all the little. We try to test, but we don't test it. We can't test everything.
Rapid feedback. You can check out some of these neat things. You can use an iPad or an Android with CircuitPython, MicroPython, and there's this neat block level device for CircuitPython remote files.
Interesting.
I know, isn't that cool? So it's you can. Yeah, I know, right?
Interesting.
Yeah, you could do that over like a remote host. That might be good for our little kid toy.
That's right.
Yeah.
One of the things that I looked into, right, because it's when you do UART, you can do like UART over web, right? Because you just send data back and forth. And so we have web serial that we have a REPL for. But how do you do file transfer? And I was like, oh man, I wonder if you could write like NFS or Samba on like a low level microcontroller. But it turns out it's actually a little bit too complicated. NFS also isn't supported as much, but I tried to do Samba, but it turns out there's no like microcontroller Samba implementation. But wouldn't that be cool if it showed up as a disk drive and you just like dragged your files over?
Yeah.
Maybe when we get to the bigger chips, we can do that, as we get to like the M7 chips.
On a unrelated note to this, but I was just reading about this before we started doing some of our shows today. There's a lot of talk about ChatGPT and Copilot and Ghostwriter and all these things that some of it is for human language and some of it is for programming. The programming stuff's interesting. I saw someone today was talking about its Replit. They have something called Ghostwriter, which helps you write code. And on one hand, it could be dangerous because, you can get a bunch of code that's nonsense or garbage. On the other hand, what they did is they hooked it up in the REPL. And I thought that was really neat because the AI was using code and going back and forth with the programmer, and they had it plugged into a REPL, and eventually it got it right.
Huh.
Because a REPL is interactive. Like, that's one of the things I really like about CircuitPython and just Python in general is you can kind of do very fast iterations. When we were doing Cricket for AdaBox and we were doing a lot of robotic stuff, it was just like kind of I can't imagine compiling and then sending it to a microcontroller over and over. But anyways, check that out. There's a lot of, I think that's going to be a more interesting use of some of this stuff other than just like, oh, write the code for me. I think it's going to be more of like a partnership between a huge amount of human language ability that can get you the code that you're looking for and then interactively working on it in a REPL. Anyways, so the news of the week that I wanted you to talk about later, because someone's going to ask about this, is and we have it as a new product too.
What is this?
Is a Raspberry Pi debug probe. Why in the world would Raspberry Pi release this, and what does it do? And why is it interesting?
So the Raspberry Pi debug probe, it's an official product from the Pi Foundation. And of course, it features the RP2040, and it's like RP2040 debugception, right? Because you're using an RP2040 to debug an RP2040. The RP2040 chip is based on the ARM Cortex M0 Plus chipset, which means it has SWD debug, which is actually nice. It's a standard for debugging these chips. And if you're used to, like me, if you've done like printf debugging, which works, totally fine. You print where you are and you just sort of figure out where your program's crashing or what the values are. But once you get to any complexity, GDB step debugging is really the way to go. And that's where you connect to it and you can step through line by line the code and print out all the variables. I mean, it's very, very powerful. I love using GDB for more complicated projects, and it will definitely help you find like those really tough bugs. You can have it watch a variable. When the variable changes, it interrupts, or when you enter a function, or when you exit a function, or whatever. It's awesome. Um, but the issue is, SWD, the programmer dongles are kind of expensive. Even the cheapest J-Link right now is like $60. They're very good. They're totally worth the money. But if you're a student, or just beginner, you don't want to spend, you start at 60, it easily goes up to $1,000. For these debug probes. So this is a SimSysDAP compatible debug probe that is designed to work with OpenOCD, which is an open source debug connector, and then you would use GDB to step through your program and see where it's failing. It's useful for when you're writing code in Arduino or C, C++ using the Pico SDK. In CircuitPython, you would use this to debug the CircuitPython core, not to debug your CircuitPython program. I mean, you could, but it would be weird because your code is being interpreted, right? But for people who are doing, Arduino or C, C++ programming, this is really great. It's got 2 ports. We'll talk about it in the new product section, but there's a UART port. So it also has a USB to serial converter, which is handy because you can also do printf debugging. And then the debug port, which is that SWD port. And there's on the Pico H, there's a plug that it goes in directly, but these pins can be plugged into, it comes with cables, it can be plugged into a breadboard or soldered. A lot of our designs, like the Feather, have a SWD connector you would just plug these pins into instead.
All right, get that delivered to your inbox every single week. Python on Hardware newsletter. Go to adafruitdaily.com. It's a completely separate site. It has nothing to do with your store. We don't spam you. We don't harvest your emails. We don't do anything like that. That's why I have a separate site just for newsletters. So go check it out at Adafruit Daily. Free service provided by Adafruit just to show cool stuff with Python on hardware. All right. Open source hardware news and more, and our guides. We have a bunch of guides this week.
Lots of guides.
What's on the big board this week?
New
You want to start at the bottom, or you want to start?
Well, I'm trying to remember. I think
Ann's guide just went in.
I think this camera guide. These are updates.
Yeah.
Can you make this a little bigger, or is it small on purpose?
What, the size of it?
No, it's fine. Okay, this is good. Yeah. So this is the guide for the OB5640 camera breakout. We're going to get into camera stuff, and this is sort of our first foray. This is a high resolution camera with a wide angle lens. We have support for it in CircuitPython, and there's some support in Arduino as well. In CircuitPython, we recommend the RP2040 and the ESP32 series of chips. The S2 and the S3 in particular both work with this camera. The 7051 technically works, but in reality, we had so many problems with it that we don't really recommend the 7051 anymore. This full tutorial, you can be pretty easily, once you've got it wired up, get JPEG data or raw binary data, and the JPEG data can be compressed in up to like, I think, 1080p. So useful for getting snapshots and also processing live data. And you can use it for like machine learning stuff, photography, videography, making animated GIFs, all sorts of fun stuff.
Okay, next up.
Can you scroll down? I just want to see what's below this. Did we do the Gravatar guide? I think that's
I think maybe we mentioned it last week, but I'll mention this as well. So Gravatar, when you sign into a website and you're like, whoa, I remember I had that icon like 10 years ago. There's a service Gravatar. You probably set it up at some point. So if you want to change it, because Gravatar is something that's used on like millions of websites, it's a project by the folks to do WordPress now. We use it in our account system and also on the forums. So if you want to check out how to change it and also check out the privacy policy, they have a good one. We have a little how-to guide because I looked around and like there's nothing great. So I'm like, hey, Ann, you should write a guide because Ann just updated her at Gravatar as well. So I gotta do that on mine because I think I have like the old Adafruit logo.
Yeah, we also have the two guides for the NeoKey and micro SD card BFF. I think Liz did that this week. We've got a bunch of updated guides, just fixing some stuff. The e-ink display got an iSpy connector, so that now has iSpy documented. We're slowly going through. Nice, iSpy in the back. But we're going through and doing all the e-ink displays slowly but surely as they run out of stock.
Yeah.
Okay. So then we got the Meowsy Cat piano
You showed the video
line
for
out.
that.
So that's just, we're starting the first hack, which is just adding line out, and then we're going to redo the whole guts with a RP2040. A lot of our IoT boards like this Huzzah and the ESP32S2 Cutie Pie are getting Whippersnapper Essentials pages. So maybe like go to the Cutie Pie. I think this one is in progress.
Yeah.
So so Whippersnapper setup. Well, that's the original one. Keep going, go to the essentials. So we're adding these essentials pages that let you get started with like analog inputs, reading a push button.
Quick starts, I feel like.
They're quick starts. This one, I think it's in progress. So there's some images missing. But we're going to have, for every board, we'll have the wiring diagram for that board. So it's more specified. So maybe go back, because I think that one was he was working on it. So go back one.
Yeah.
Go back one. Go back and then click on the Huzzah. I think that was the one that scroll down and then essentials. Let's see if this one and scroll down.
Yeah.
And
No.
click on analog input.
Yeah.
See if this one has the. No, I think that they're still working on the images. Can you see most?
Yeah. Well, what? What do you think?
I want to see.
Ladyada.
Yeah. So this one, for example, the first one. So using this on Whippersnapper, we have the image of the board itself. So every board will have its own unique images for the tutorial.
Okay.
So we'll do that. I think images are just loading really slowly too, which is kind of odd. Okay.
There's a billion things on this computer.
Yeah, there's computers.
We're streaming. Okay.
All right, so then go back to the front page.
All right, anything else?
Yeah, we'll show the Whippersnapper essentials. I think the images are still not loading. And then finally, there's not favorites, but one of our favorites is this floppy thumb drive that has a color display. This is inspired by a Nanoraptor tweet render of a floppy disk that had display in it. And we're like, well, let's make that real. And so Anne and Noah and Pedro and a couple other folks from the Adafruit team got together and made the whimsical physical.
Alrighty. Let's do some advanced manufacturing made in New York City factory footage. And that's factory. Let's do some 3D printing stuff. We got another twofer. Let's do twofers tonight. We're going to do this 3D printing speed up But first, we're going to play a really cool video that shows all about Whippersnapper, the new Pedro did. And that's part of Adafruit.io. And you can start using Whippersnapper right now. It's free. It's no code. It's easy. So we have all those essentials that you were talking about from the guy.
That's right. That will load on your browser because your browser's not streaming.
Yes. So here we go.
You can build projects with NeoPixel LEDs and Whippersnapper, Adafruit's no-code solution for IoT projects. With Adafruit.io and Whippersnapper, you can control NeoPixels with an easy-to-use web interface. Just tap on the color picker to change the color of the LEDs. Whippersnapper now has support for both NeoPixel and DotStar LEDs, allowing you to make glowy IoT projects. You can create custom triggers to make LEDs reactive, time-based, or even a scheduled event. In this demo, we have a motion sensor set up so the color of the NeoPixel LEDs will change whenever motion is detected. With Whippersnapper, you can plug and play sensors with StemmaQT to create sensor-aware projects. There's a huge list of supported sensors like temperature, humidity, and much more. 3D print our enclosure designs to make projects using the Raspberry Pi Pico W or an Adafruit Feather with StemmaQT breakouts. Use a light sensor to detect when the room is dark to turn on a strip of LEDs. You could even have the colors of the LEDs change depending on the temperature or humidity. Whippersnapper makes it easy to set up a new device. Just search and choose a supported dev board with Wi-Fi capabilities. The site will walk you through installing the firmware onto your device and set up your Wi-Fi so you can quickly get up and running. Once our dev board is set up, you can easily add NeoPixels or dot stars and start glowing. The color picker allows you to quickly test your LEDs so you know it's working. Our 3D printed case secures a pair of StemmaQT sensors with a command hook so it can hang on the wall. 3D printed diffusers cover up the LED strips and make the space look much cleaner so they can blend into the surroundings. Command hook clips keep the LED strips in place without the hassle of drilling into your wall. Our enclosure is mounted near an outlet and uses colored filament that complements the color of the walls so it looks nice and clean. We hope this inspires you to check out Adafruit's Whippersnapper and start using LEDs to make glowy IoT projects.
Okay, and don't forget, before we go on to NPI and the new products, the code is ClearKnob or ClerkKnob. 10% off all the way up to 11:59 p.m. or whenever you turn the code off. Let's kick it.
On NPI.
This week's INMPI, brought to you by DigiKey, is Infineon. Ladyada, what is the new product of the week this week?
Okay, I'm glad you asked. This week's INMPI is, it's a long one, the Infineon BGT60 LTR 11 AIP,
Right.
which, yes, it's my favorite. And this is a pretty amazing chip, and we'll show it maybe on the microscope later. It's a all-in-one 60 gigahertz radar module. That's not only is it a full like radar module, but the antenna is built in as well. Very cool. So this is a 60 gigahertz Doppler radar sensor. It's only about 6.5 by 3.5 millimeters wide. Got a BGA pads on the bottom, and then the cool like weird gold thing with squares with feet. Those are the antennas on top. It's configurable, but it also has a very basic autonomous mode where it just tells you if motion was detected and the direction of the motion, whether it's coming towards or away from you. But for more advanced usage, there's also an SPI interface, and pretty much everything is integrated. Like you basically just need a crystal, a couple of passives, and you're ready to go. So Doppler, in case this is a nice image from Wikipedia, Doppler, in case you're not aware of how this works, is compared to infrared reflective sensors, right? Infrared reflective sensors like IR and time of flight, they send a wave of light and then they measure how much was reflected back. And so it's like a quantity. Time of flight, they measure the time it takes. Doppler's a little bit different. What it does is it can detect the motion, because as something's moving, the high frequency waves that you bounce back, the frequency shifts just slightly, called the Doppler effect. This is commonly when you're in high school or grade school, when you're listening to a siren as it, a fire truck goes by, the Doppler effect makes the frequency change as it passes you. And that's, that motion. Yeah. Wow. So that effect of things in motion, the waves that are emitted or hitting them that bounce back, change in frequency slightly, that's the effect. And so you can measure the speed of something. And it's often, again, Dopplers are used for radar detecting of cars. So you have those radar detector guns that traffic police use. They bounce a radar off of you. They can tell how fast you are going without having to count ticks or something. So and mailboxes. So, we've talked before about using radar for detecting speed, but another useful thing that these radar Doppler sensors are used for is to detect whether a human is there. And usually you do human detection, not with time of flight sensors or infrared, you'd use it for a hand, but usually you use a PIR sensor. And PIR sensors are great for locating and measuring whether something that emits infrared light, heat, is moving. So people, large animals, you'll see these often in restrooms where, when you open the restroom, it detects that there's a human there. Or sometimes if you're in front of a door, it detects and it opens the door. PIR sensors are very common, very inexpensive, and they've been around for a long time. There's a couple downsides of PIR. This is from Infineon's documentation, and they did a really good job here. So PIRs, I will say, they're going to be less expensive, but there's a couple things where radar's sensors are better. So first off, they can have wider range, 24 gigahertz especially. You can be a couple meters range or more. And like with the car detection, it can be quarter of a mile. One thing that's nice about radar compared to PIR is PIR only detects if there's movement, whereas because you have that Doppler effect, you can tell whether something is leaving or entering the area. Like it detects the motion forward or backwards. And so their examples of an automatic door, right? You only want the door to open as people are entering and not exiting. Like it knows whether you've just passed the door or whether you're entering the door. This is like the science fiction movie thing where it's like, how does a door know which direction you moved? Because they have radar sensors in the future, not PIR. The most important thing is that you can put a radar sensor behind a material, and it doesn't have to be, it can be opaque to light, right? Whereas PIR sensors, they have a lens and you can't have anything blocking the lens. Like it has to be exposed. And so you can see a PIR sensor because it's got this gray or white blobby, lens thing. Whereas radar can be put behind a material like wood or plastic. It doesn't have to be visible. So it can have or glass, it can have a much nicer look. So overall, for a lot of things like sensitivity and resolution and direction and distance and different materials and size, they're also, these sensors are much smaller than laser or, which is, time of flight or ultrasonic sonar or infrared or PIR, but they're not as cheap, right? So they are less expensive and they're a little bit more complicated. But this LTR, the BGT60, is a great sensor to get started. So here's the block diagram. Again, it does kind of everything for you. You wire it up, has an antenna built in. You just have to give it a crystal. It can run on its own. It's got a P detect and T detect at the top is the built-in capabilities. The mode select at the top, the QS 1 through 4, you can tell it whether you want it to be in autonomous mode and how sensitive you want the autonomous mode to be, or there's an SPI mode as well. Compared to this BGT24, this is the 24 gigahertz. Again, the 60 gigahertz, it's higher frequency. The antenna is much smaller. You can see the antenna on this shield. It's a 2 inches by 1 inch. It's small, but it's not tiny. The BGT 60 is much, much smaller. One thing to note, power supply, you will need to give it 1.5 volts. That's logic level as well, I think. And so just be aware when you wire this up to your 3-volt microcontroller, you'll need to give it a regulator and level shifting. If you don't want to deal with the BGA package, you can get it in this cute BGT60 LTR 11 IAP shield. It's minimal, right? It's not that much bigger than the chip itself. And it has the crystal, I think has some a regulator built in. It only has the 4 pins though, power, ground, motion trigger, and directional. So it only gives you like 4 bits, whether somebody's moving or not, and which direction they're moving in towards or away from the sensor. But there's also a little dev board that you can plug it into, but that's like the most minimal solution. There's also this like fancy board. That's the thing I showed yesterday, the demo board, which has a main core on top of it as well. And I think it's a Cypress chip, and then the Infineon radar shield at the bottom. There's also this really cute all-in-one. It's called like a sensor to go board. It has the SPI and GPIO pins brought out, and also the sensitivity and threshold timing. Just like a PIR sensor is configurable with 2 mini tripods. And you can see the sonar on the right. You can even sort of see the, not sonar, the radar on the right. You can even see the antenna. This is the pinout. If you want to integrate this, it does come on a pick-and-place reel.
You can build
But if you don't want to do the layout, I did check out an Ultra Librarian, which is linked to from DigiKey, has the pinout and pad definition, so you can just download it directly into your CAD program. There's actually 2 places on GitHub. So there's a radar. This is the shield that just has the GPIO pin. So this is a very simplified library that only does like the GPIO. There's also a separate library file for SPI mode if you're interested in. The SPI mode, there's example code. You'll have to do the hardware abstraction layer, but you can set all the little tweaks and knobs you want to customize the GPIO. And of course, you can still have IRQ output if you want to be told, when the sensor is triggered. But again, I think that, it has this built-in simple mode. You can start with that. And then if that doesn't work for you, upgrade to using SPI control.
Available on DigiKey, there was like 4,000.
There's 4,000. There's a lot.
Yeah. So we're going to do 2 things. They have a cool video. We're going to play that. And then we're going to bounce out of IMPI and we're going to show, because we're testing out microscope stuff. So we didn't want to have this as part of IMPI. So we're going to just do that really quick. So see you on the other side.
Hi, I'm Arushi Jain. And as a radar system application engineer, I often get told that radar is too complex. We've been listening, so let's move away from complexity and go towards simplicity. This is our BGT60 LTR11 shield. In the center here is the 60 LTR11 MMIC with the antennas integrated in the package already. This reduces complexity to design antennas at the user end. It's a really small package with an extremely low power consumption. It supports different modes of operation, including a completely autonomous mode without requiring any MCU or any signal processing. Now, isn't that simple? So let me show you how this works. All you need is a battery connection and connect the power supply here. You see the LEDs start detecting me already. The green one is for motion detection, whereas the red one is for direction detection. As I move my hand towards and away, you see the red one starts blinking and stopping. When it is blinking, it means I'm coming towards it, and when it stops, that means I'm going away. The radar also works through different materials. As you see, I have it covered here with a plexiglass, and it still detects my hand movement. It's a Doppler-based motion radar sensor. It detects a human target up to 5-meter range and is also less than 5 milliwatt in power consumption.
All right, we previewed the idea of this in our top secret, and now we have a chip and we have it set up, and we're going to continue to figure out. We have a kind of an old microscope, but it had HDMI out. So the idea is we would do like a really cool close-up video while we're playing chiptunes, and the segment is called chiptunes. So you can hear a little bit of the music in the background right now, but then here's Ladyada. And you can see.
Oh, I have to.
You gotta.
Oh, my arm's not long enough.
Like yoga.
So yeah, we'll tweak
What I'll
it.
do is I'll have a camera like directly on you.
Yeah.
Maybe I'll
Traces.
'Cause it'll be like a reaction video. Be like, oh, look at Chip.
Hold on, maybe I'll show that.
Yeah.
You can see the trace antenna on the opposite side.
Yeah.
You can see the part marking here. Okay.
All right. So that's the idea. Okay. Before we go off into your product land, don't forget, it's clear now. Let's kick it. No. First up.
This is the AGS O2MA sensor. It looks a lot like those like DHT 11 or 22 sensors, and it's actually made by the same company, which is why it looks the same. So the AGS O2MA has a MOX gas sensor inside and a little microcontroller chip that acts as an I2C peripheral. Basically, it means that you can use this as a low-cost and simple TVOC, total volatile organic compound sensor, gas sensor, for ethanol, methane, and similar gases. It can detect those in the air. It basically does a simple calculation to do parts per billion. You can also read the gas resistance. There's only one gas resistance plate. It's, not super calibrated, but it's very inexpensive, and, plug and play, works with 3 to 5 volts. One thing I will note about this sensor is it needs to run at under 30 kilohertz clock for I2C, which is unusual because the default I2C clock for many boards is 100 or 400 kilohertz. So you have to tune your I2C controller to run. I use 20 kilohertz, for example. Some controller chips like the RP2040 and ESP32 were happy to do this. I told it, hey, please run at 20 kilohertz, and they're like, sounds great. So did the Atmega 328. But there are other chips, the SAMD series, that was not very happy about running at that low speed. And so just be aware that you have to make sure that maybe check on an oscilloscope that you can run your I2C controller at 20 kilohertz before you pick up this sensor. Other than that, it works pretty well.
Next up.
We have a new camera lens for the M12 camera from Raspberry Pi. This really nice lens mount on the camera allows you to plug in, screw in different lenses. We've got like wide, and we've got, I think, a narrow telephoto, and this is a portraiture one. So this one has a narrow field of view, and also I think a narrow focal range, and so it'll focus nicely on a face and get like the depth of the face, but it'll kind of a blurry background for that cool modern portraiture look.
Yeah. All right, next up, this is what we were talking about earlier.
Yeah, this is the Pico Debug Probe Kit from Raspberry Pi Foundation. So this is kind of an all-in-one SimSys stat board for debugging RP2040, but also other chips as well. It's also, by the way, an RP2040 dev board that you can just reprogram. You can load whatever code you want on there. It's got 2 JST SH connectors, 3-pin, and it comes with 3 sets of cables. Let's go to the overhead because I feel like this would be a
Yeah,
good...
we have a new overhead.
We have a new overhead too, so let's test it
All
out.
right. So you can, if you move your head over, people could see you as you're doing this too. Look at that.
Oh, I have to...
Or not. I can get rid of you.
Yeah, maybe get rid of me because this is...
Okay,
I'm
there you go.
not ready for that yet.
All right.
Okay, so
I
hold
want to
on.
hit the focus.
I know. I got this new. This is all new, so you're gonna like look at this. Okay, so this is your classic Raspberry Pi Pico H. And it comes with this connector at the end. And earlier Raspberry Pi Pico boards came with 3 pins at the bottom instead. But I'm showing this because it's convenient. You can show that this plugs in nice and smoothly. This is the cable that comes with the Pico probe, and then you plug this into, this is U for UART and D for debug, and you can plug this in here nicely. And now you still have to separately power these two, but then this shows up as an open OCD device that you can then use to run GDB for debugging with step debugging, where you can actually go through line by line. You could observe variables. You can have it break and it enters a function, leaves a function, when a variable gets changed, when memory is attached, whatever. It's very, very powerful. And if you like to do, if you have the old our Raspberry Pi RP2040 boards, you can use this cable that has the plug headers, or this version that has the socket headers. So those are 2 options. And then there's also a USB to serial converter as well built in. So this other port, the one labeled U, gives you ground, RX, and TX that you can use to read and write UART data for printf debugging. There's of course a UART here, but sometimes, especially when you're doing like USB host stuff or USB debugging, you don't want to use the printf debugging on here. You want to use printf over a hardware serial pin, like one of these, in which case you can use the USB serial converter and one of these, plug them in, and you can do both GDB step debugging and printf UART debugging as well.
Okay. Next up, we had that code.
Clear knobs.
Clear knobs.
Yeah, these are
Clear
clear
knobs.
knobs. They've got
We have a bunch of colors, don't we?
we have a bunch of colors.
Black colors.
So clear is made out of a different material, so it's more expensive. I do want to show that on this side of these, this is nice because it shows all the different angles. These are clear knobs. They are used with 6mm D shaft or T18. You can use either because, as you see, there's a little, I think it's like a 1 or 2mm set screw. And the top has a black marking, so you can see the positioning of it. Great for potentiometers or rotary encoders, either one. And they're clear. They're clear knobs.
Yeah.
FYI.
And you can pick
clear
different colors.
Yes.
All right. And then the star of the show tonight, besides you, Ladyada, our team, our community, our customers, everybody who makes this go is
the ESP32 S3 reverse TFT. So many words and letters there. It's a ESP32 S3 Feather, as you can see here. And so let's look at the back first. So the back is the front and the back. Okay. So this is you got your ESP32 S3 mini module, 4 megabytes of flash, 2 megabytes of PS RAM, dual core, 240 megahertz Tensilica processor with Wi-Fi and Bluetooth Low Energy. It does not have Bluetooth Classic, by the way, but it's the latest S3. And then you've got all the little accessories that you would want on that back, and I'll show this on the overhead. It's got USB-C for data and power. It's got a LiPo battery that charges automatically, reset button, a STEMMA QT port for I2C, 2 3.3 volt regulators, one for the I2C port, one for the main board, so you can have like ultra low battery usage and power. Max 17048 battery monitor, so you can check your state of charge. A little NeoPixel for NeoPixeling, and then all the GPIO you need: I2C analog input, SPI, UART, etc. GPIO plenty. And then on the flip side, you get a 240 by 135 pixel IPS display, very tiny display, with, again, the reset button's also on the front because it's useful, and 3 GPIO 0, 1, and 2 connected to buttons that you can press, and you can press them to make it do stuff. So I can actually show on the overhead.
Okay.
Oh, I got this thing. So on the overhead, you can see the buttons. I press D1, D0, D2. So we already have an ESP32 S2. This is just the S3 version, so it's actually kind of the same pinout and everything. Reset is handy because you can enter the bootloader. Although I don't think it'll enter the bootloader because it will. So there's a UF2 bootloader already programmed in. For drag and drop, of course, you can erase it. This works with Arduino and CircuitPython because we have support for both of those modules. And the reason I like the reverse mount style is that you can put like a feather on top, but then the TFT isn't blocked, right? So if you want a feather wing, you want to add a GPS or real-time clock or LoRa radio, and then you still have the TFT on the front. Hold on, let me just shift this down a little bit. You still have the TFT on the front with some buttons that you can use to have it do different things, display status, sensor output, battery warnings, etc. And yeah, I think it's good for IoT projects. We'll have Whippersnapper support. And again, like I said, CircuitPython and Arduino. All in one. I mean, you can do a lot of projects with no soldering. Just plug in the STEMMAQT port in the back and you have buttons in a display.
All right, let's new products.
New, 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 new.
All right, don't forget the code is ClearKnob. We have some questions lined up. You can continue to post them over on Discord if you want, but we're going to do a special top secret here. Get out ready.
Yes.
All right, we have at least two things.
Okay.
First up.
First up, yes, we did a after hours Desk of Ladyada where we actually tried out some of the AV stuff that we've been playing with, but also talked about this board. So this is the RP2040 Bones feather. So I took the RP2040 feather and just squished it off so much that there's space over on the side to add more things. And in this case, I added a DVI port. It's got some resistors in line. It's also got your head's in the way. Maybe you could kind of go.
Man's always
Thank you.
I'm a big head.
Gigantic head. You also got the utility and CEC pin brought out. I2C is connected through, so you can actually do EDID detection. There's a STEMMAQT port over there. And then at the very bottom right, there's HPD, so it's a hot plug detect. So we've been doing some hacking with Pico DVI, and I think this would be a great little dev board. I also want to redo the Scorpio board actually now because we have more space. I've done more squishing.
Okay.
But I have to fab this first to make sure, because this is all 0402ified. I have to make sure that everything still works.
All right, and then here comes the big deal. Ready?
Yes.
You gotta put it in there because it's.
Well, this is even better because it's like the reveal.
Dun, 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 dun.
Dun, dun,
And then
and
you're
I'm
gonna
gonna angle it.
angle.
I was going to say England.
Do you want me to have you there so you can talk about this? Yeah, there you go.
Yeah, maybe I'll talk about
Yeah.
this. Okay, because I don't have to. Maybe I'll point at stuff with my pointer. So this is the Feather M7, the Metro M7, first prototype with the new fancy silk screen. Thank you for zooming in as much as possible. So
Yeah,
this is, you can see, yeah, I'm just getting the light so you
I'll
can see
back
the
it out.
IMX. And then on the back, let me back it up because I want to show Phil B's beautiful silk screen. And I'm gonna just mess around a little bit with the. I think that's a good tilt.
Yeah,
Yeah, it's tough. Okay, maybe I'll hold it
that
out.
looks good.
So this is the silk screen. So wanted to take inspiration from the 7 line, which is purple here in New York City, and it has the newer trains have this cool like what stop is next display, and so Phil B kind of took inspiration from that and showed off what's available on this Metro board. So this is whenever we have a new chip, we tend to do a Metro because we've got the SWD connector, lots of GPIO. It's kind of easy and spacious. A STEMMAQT port, different power out inputs, USB, DC, 3-volt output, has Wi-Fi, has the jumpers for the boot select because the bootloader is kind of funky on the IMX. But this board is pretty much ready to go. We've got panels fabricated, and we're going to release this shortly. So this will be pretty exciting to get a new chip going. I mean, like the chip shortage, we couldn't do this because of the chip shortage. We had the design done like 2 years ago, but we couldn't release it because we couldn't get microcontrollers. But now we can.
That's top secret.
It's top secret. Not out yet. Don't ask.
Okay, we're going to bounce right to questions. I lined some of them up, Ladyada. You can start to look at them and answer them. right away. That might be faster.
Yeah.
Ready,
Yeah.
set.
Okay, do you want me to read the questions?
Do you
too?
want-
Yeah.
yeah.
Okay. So I first learned about resistor packs on Desk of Ladyada. Is there something equivalent for SMD capacitors, capacitor array to make design smaller? Yes, there are SMD capacitor arrays. We have used them once in a while. There was one time in which we had a board with 2 crystals on it. And so we were like, well, instead of having 4 15 picofarad capacitors, we just used a 15 picofarad capacitor array. That's the only time I've used them. I don't use them as often because you often don't want the same value of capacitor all next to each other. Like usually you have a 0.1, 1, 10, and then another power pin, or power supply, 0.1, 1, 10. You don't tend to have 4 0.1s in a row. But if you did, for you have a bus line and you want to have 10 or 20 picofarad caps on each one just to reduce ringing, yes, capacitor array. Okay, I have a small part where I'm using PID 2090. What I want is on the screen to be displayed on a web page, integrated web server in real time. My thought is to use HTML5 canvas and read the videogram and somehow display it that way. I think that's a 3.5-inch TFT, 2090, in which case you just use the Raspberry Pi and wire it up to the Raspberry Pi using, I would actually just use the Pi TFT, which is the plug-in version of the 3.5-inch, or you just follow the same wiring and then just mirror the HDMI display onto it, and then you can do whatever the heck you want.
Okay.
Octoprint direct GPIO for a Pi camera. I don't know. You'll have to ask Octoprint people. I've never actually used Octoprint. Will Arduino Classic Shields be compatible with the new Metro M7? A lot of them will be, but note that there's no Arduino support for the Metro M7. Right now, there's only CircuitPython. So you'd have to use them within CircuitPython.
Okay.
For the Pi Debug Probe, we're going to add that debug header to the RP2040 base feathers as a new rev. Not all of them, because not like that DVI one didn't have space, but the generic like RP2040 feather, yeah, I'll probably swap out the SWD for this connector because it sounds like they've stabilized on this is the standard. Okay, any thoughts you would use as a switch to detect 2 physically light objects in contract moving apart, such as one Lego brick pressing down towards another? Most switches I found require too much force. So physically light moving apart. Yeah, physically light stuff is tough because you don't have a lot of pressure, but there are some fairly sensitive FSR, the force sensitive resistors. Those might be fine. I'm trying to remember what else would be a good contact. Yeah, it's really tough. Like you want like a piezo, maybe. There's some piezos that maybe when you press on them lightly, they would detect motion.
Yeah,
It's amazing.
I'll do the next one. Person's working on launching their first product brand. What are a few things you wish you had known or done differently when you first started Adafruit? Well, if you really want to, you can watch all of our shows going back to kind of the very early stages of Adafruit, especially when launching a product or brand. Looking back, I wouldn't change a thing because even the things that were terrible, it makes you robust and you have knowledge and we shared it. But I'll say this, and maybe you need to hear this. Reassurance is really the thing that I wish there was someone saying like, hey, you're publishing every day. That's weird. You have a blog. It's an electronics company, but that's the right thing to do. You're doing a show every week. It's super weird. Who's going to do an electronic show every week? The idea that we're telling our story each week in some way, and it's now part of the entire culture of the company in addition to sharing our files and code. I think that was like just one of the things where it'd have been nice for someone to say like, hey, like that's going to be the weird thing that works out and it's okay. So find people that kind of give you that thing, because it can get hard and lonely, more of like a personal thing, because like it's a lot of work running a company. So I think that surround yourself with really good people, because I think those are the times where it's like this is really hard. It's not necessarily the work, it's sometimes the emotional overhead of a lot of things.
Yeah.
You can do this one and then I'll do the last one.
Okay. With many boards having quick connect meant for I2C and bring up 2 GPIO pins that are capable of general IO, is there any engineering comments you pass on someone middling the pins for other use? Totally go for it. It's just be aware that somebody might plug I2C into your design. I have done it. I have said like, oh, like we have I2C and it's not being used for I2C. They're just connected with GPIO. Use them for like a button for wiring, but it's, you know, it's tacky. I'm okay with being tacky, but it's still tacky.
Status of AdaBox. I love answering this one because we sent off kind of the almost final new revised design for all the parts that we can get. So things are moving swimmingly. So
Half the components got discontinued. I had to
Yes.
start over.
so the good news is it's absolutely going to ship. We're going to see how fast we can do it, but we're still aiming for the next couple months or so.
Yeah.
Next up, you want to do these?
It's possible to use display port plugs instead of the D sub DVI for Scorpio bones. Same signal, different connector. I would just go with the standard connector I've got right now. It is more popular than DisplayPort, to be honest, and there's adapter cables. I'd rather just use the one I've already got stocked.
Yeah. We've been great to trivia, Chris. Yeah, I think we will. We just have to figure out the right way to do it.
Payphone here.
Yeah, I think we will because as you can tell, I just put on social media this setup. I think I'm going to do it so we can do the payphone stuff again.
The payphone, the clear phone.
Yeah, we'll probably do one of
It'd be
those.
funny if we like wheeled the payphone down the hall.
Reaction video watching the first video went, oh yeah, we should probably do that.
What?
A reaction video of us watching like our first video that we did.
Oh, is that the thing now on YouTube?
It's a thing really anyway.
Okay, we'll be like, wow, I look adorable and young.
I'm using the teenage filter from TikTok now. Okay. Them's the questions. We got.
Okay.
Thank you, everybody.
Sweet, thank you.
Very much
We
appreciate
did
it.
it.
Yeah, just a little bit of a reminder. ClearNob is the code, 10% off in Adafruit store, all the way up until 11:59 p.m. We thank you very much for joining us on this Wednesday night. Thank you so much. Be good to one another. Share information and knowledge, and it's really cool to see a lot of people building companies and brands and products and ideas off little bits and pieces that we can get out in the world.
I feel like people are trying to get back into doing. I mean, like the last 2 years or 3 years were so emotionally exhausting. But if you made it this far, like get back into doing stuff. I love seeing people slowly kind of peeking out.
There's folks we know that are like, we're the survivors and like we're now we're crawling out of the rubble and we're here. And then there's new folks that are around that are starting to jump into electronics. And it's a really good time to jump into electronics. Never have you been able to do so much with small budgets.
Right now is a great time, especially since like, and I'll be honest, like we have a lot of inventory overstock, and so do a lot of people. So parts are going to be really cheap soon. I think there's going to be a lot of overstock, and you'll be able to buy components. If you want to go into a manufacturing run and you're using something that was overstocked, you can get stuff for pretty cheap.
Thanks, Zay, running some stuff behind the scenes here at Adafruit, and this has been Adafruit Production. We'll see everybody next week. We have a bunch of videos and shows and more.
Yay!
Here's your moment of Zener.
Bye, everybody.